This is what energy efficiency actually looks like, specifically the inside of a building's actual energy analytics. Understanding how these data are collected and how they can be used to improve energy efficiency is crucial for fighting climate change. I'm Ben Leffel, and I'm going to show you a real-life example of exactly how this works.
This is what the actual energy use of Reines Hall at UC Irvine looks like, specifically the third floor physics offices. Now, the reason why this data is visible is because UC Irvine uses an advanced energy analytics systems for most of its buildings called Skyspark. Now, what you're looking at is up top, the BTU per hour, or the energy use used by the heating system on the third floor physics offices, shown over time here. So the y-axis shows how much is used, and over time we travel right here and we see thousands of data points being gathered every minute. This is how it is tracked. And down below we see the occupancy sensor, which has two settings for that floor, occupied and unoccupied. And when the sensor is occupied, it means that it is detecting movement. Somebody is in the building. And correspondingly, it turns the heat or the AC on to cool people down, heat them up, whatever time of year it is. Let's zoom in to a more specific time this particular week. Now, here's how engineers figured out that energy was being wasted. First of all, you see that when the occupancy sensor picks up movement, where it is on the occupied position, it turns the heat on, because that is what it's supposed to do. Now, here's the problem. We see that virtually all hours of the day, even 2 a.m., 3 a.m., there's energy being used. It's detecting movement, and thus energy is being wasted. It's being turned on. So why is that? And with all that wasted energy, it's obviously a big problem, and so engineers sought to figure out what the issue was. And they deduced that it was an oversensitive sensor. It was so sensitive that the sensor was picking up motion from something as small as a moth flying, and in the middle of the night the energy would turn on, and that's how they were getting all that wasted energy. So it was around Saturday the 7th that they adjusted the sensitivity of the sensor, so it would only pick up movement when people were actually in the building. And you could see at this point thereafter it was less sensitive and was only picking up when people were in the building, and thus no more wasted energy. And that is how they did it.
Just to recap on what we learned, the energy use of that floor is shown at the top, and the occupancy or motion sensor is shown at the bottom. It was discovered that energy was being wasted. The power was on during times of day when no one was there. And this was discovered to be the case because the occupancy sensor was also firing or misfiring. It was too sensitive. Something as small as a moth might set it off. So engineers were then directed to adjust or lower the sensitivity of the occupancy sensor so it would only fire or activate the power when people were actually in the building during normal operating hours. And the result was energy savings. And that is what building energy efficiency looks like. The result, of course, also being the reduction of greenhouse gas emissions attributable to the energy use of that building. This is critical for organizations, be it a university, business, or government, to track progress towards building energy efficiency and achieving real decarbonization. I'm Ben Leffel, and I hope this has been interesting and useful.